NMR spectroscopy is perhaps the highest yield lab technique on the Chem-Phys section of the MCAT. It's also, unfortunately, the trickiest one. So let's go over the four major components of NMR spectroscopy: signaling, splitting, integration, and shift, using this molecule over here. So the first step over here is I draw this vertical line of symmetry to determine if the molecule is symmetric. It is indeed not symmetric, so each of these carbon atoms are unique. As you can see, because we have three unique carbon atoms, we have three unique groups of hydrogen atoms. That's why we end up with three unique signals on the reading. So that covers signals, the number of unique groups you have. That's going to determine the number of signals. Next, let's talk about splitting. So that refers to why you have multiple peaks within each signal. The way to determine how many unique peaks you're going to have is based on the n+1 rule. What's the n+1 rule? Well, n represents the number of hydrogen atoms on the adjacent carbon. So let's take this carbon, for example. The one adjacent to it has two hydrogen atoms. So you have 2 plus 1. So therefore, the red hydrogen atoms should have 3 unique peaks. If you take a look at these blue hydrogens over here, they're attached to a carbon atom over here which has 3 hydrogens, and one over here which has 2. So that's 5 total on the adjacent carbon atoms, plus 1, which equals 6 over here. Integration is perhaps the most straightforward one. The more hydrogen atoms you have of that unique group, the higher the peak is. So over here you have the most of these, so that's going to be the tallest peak. These are equal, so their peaks are equal in height. Finally, let's talk about shift. Shift refers to whether the peaks are going to be downfield or upfield. So downfield is more towards the left as the numbers increase. Upfield is more towards the right as the numbers decrease. So you can see right here that the red hydrogen atoms are at about 5, a little less than 5, and that's because they're close to this electronegative atom, which is bromine, which de-shields them. And as you get farther away from the electronegative atom, you get closer and closer to 0. Now, unfortunately, there is some memorization you have to do over here. So carboxylic acids will de-shield to 12, aldehydes to 9 to 10, and so on and so forth. Like and follow if you found this video helpful. Let me know what questions you have in the comment section down below, and I'll see you in the next video.